Morning all. Today we are going to do with the fifth experiment of your lab. The experiment goes like this. Assume you are generating and transmitting binary data from one place to another. In the sense, you are transmitting the data from one system to another system. Check whether the sent data is transmitted properly. In the sense, the sender sends the data in the form of binary and it should be received by the receiver at the other end. So, the transmitted data should be sent properly and received properly from towards the receiver. So, this has to be implemented using XOR gate, that is you are going to implement parity generator and the parity checker. Generate the input binary data using parity generator and check whether the sent data is being transmitted properly using parity checker. Okay, so we are going to generate odd parity generator. In the sense, sending 3-bit data, you are being generating 4-bit binary data. So it is nothing but odd parity generator. At the receiver end, it will take odd parity input and check whether the data sent is in a proper way or not. So it's a truth table for the odd parity generator. Input is x0, x1 and x2. Output is y0, y1, y2 and y3. So if it is 0, 0, 0 is the input, output should be odd parity. So it will generate 1, 0, 0, 0. If it is 0, 0, 1, it should be odd parity. So it is 0, 0, 0, 1. So it similarly follows with the remaining input of x0, x1, x2. So this is the truth table for odd parity generator. So ICs required to generate odd parity is XOR gate and a NOT gate. Okay, coming to the secure pin diagram of the XOR gate. So this is the pin diagram. 1 and 2 is input, 3 is output, 4, 5 is input, 6 is output, 7 is ground, 13 and 12 is input, 11 is output, 10 and 9 is input, 8 is output. Or NOT gate, we have already come across the pin diagram of the NOT gate. So this goes with the circuit diagram. So x0, x1, x2 are the input given for the XOR gates. Since availability of the XOR gate is only 2 input XOR gates, we are using 2 XOR gate. Output of the XOR gate, pass it through the NOT gate. Output of the NOT gate will be Y3. So this Y3 will help you to generate the odd parity generator output. That is Y0, Y1, Y2, Y3 will be odd parity generator output. Okay, input is x0, x1, x2. x0, x1, x2 goes to output flow of y0, y1, y2 and the generated output y3 will give you the odd parity output. So we are going to rig up this circuit in the trainer kit. So after getting the output of this y0, y1, y2, y3, this output is given as an input for odd parity checker at the receiver end. So this circuit is at the sender end. The output of this will be sent to as an input for the receiver end. Receiver will be having odd parity checker. Okay. So the circuit diagram for the odd parity checker is this. It goes like this. Y0, y1, y2, y3 is given as an input for the XOR gate. Okay. Output of this will be high. If at all it is odd parity. If it is not an odd parity input, the output will be low. So this we are going to rig up in the hardware, that is in the trainer kit. Okay, that's all with this experiment. Odd parity checker, odd parity generator. So let us go with the implementation of the odd parity generator and the checker. So first we will go with odd parity generator. So we are supposed to generate y0, y1, y2, y3 with input x0, x1 and x2. So for that we need XOR gate. So this is your XOR gate 7486. Okay, so this is 14 pin IC. Okay, we are going to use only 14 pins rather than 16 pins. Okay, and we need one NOT gate. So NOT gate, all of you know, it is 7404. Okay, so place the XOR gate IC to one of the IC base. Okay, I'll put it here. So place the notch upside, place the IC, press it gently and place the notch. So it gets fixed. The IC will get fixed to the IC base. For every IC, as we told with all these experiments, VCC and ground should be connected. Ground is 7 pin because it is 14 pin IC. VCC is 14 pin. So 14 pin is represented by 20th pin number. Okay, so this is with respect to ground and VCC. Similarly, we need NOT gate. Okay, NOT gate also let me place in this IC base. Gently press it and lock it. Okay, so again ground is 7th pin, so connect it to 7th pin. VCC is 14th pin, connected to 14th pin. So both the basic connections are being done. Now the input. So input means X0, X1, X2 are the 3 input, but we will be generating 4 output, that is Y0, Y1, Y2, Y3. So to go with X0, let me take X0 to be 3 pin of in logic input. 3 you connect it to first XOR gate. Okay. Now next take X1 connected to the next input of the XOR gate. Output of this first XOR gate will be input for the next XOR gate. So I am repeating, output of the first XOR gate will be input for the next XOR gate. Next XOR gate is 4, 5 and 6. So connect it to 4. So this will be the first input. The second input will be, that is a 5th pin, will be the input for third input line, that is X2. X0, X1 and the X2. X0, X1 connected to first XOR gate. Output of the XOR gate is connected as input of second XOR gate. Okay. X2 is connected to the second XOR gate as input. Output of this, okay, is given as an input for the NOT gate. According to the circuit diagram, the second XOR gate output should be given as an input for NOT gate, so that we generate odd parity bit that is to be transmitted across the network. So output of this, okay, will be Y4. So let me take Y4 to be 4th pin here. So this is Y4. So we need Y0, Y1, Y2. Y0, Y1, Y2 are nothing but X0, X1 and X2. So from X0, so this is X0 as I told previously. So this is X0 connected to Y0. This is Y0. Okay. X1 is nothing but Y1. So connect X1 to Y1. X2 is nothing but Y2. So connect it to Y2. Because this goes with odd parity generator. X0 is nothing but Y0 connected. X1 is nothing but Y1 connected. X3 is connected to Y3. Y4 is nothing but the output of the NOT gate. Okay, so this generates Y0, Y1, Y2, Y3. Given the input X0, X1, X2, this should generate odd parity bit that is to be transmitted across the network. So let us see the truth table whether it satisfies or it generates the odd parity bit to be sent across the network. Switch it on. Okay, so let us keep it everything off. Now, since I have given 0, 0, 0, 0, 0, 0 is what? Even parity, since the number of ones is equal to 0. Now it generates odd parity. So 0, 0, 0, 1 means only one line is high, means it is generating odd parity number. This is transmitted across the network. So if it is 0, 0, 1, okay, so it is 1. Okay, again it is odd parity. Don't go to bother about which line is high. Finally, the output should be odd parity generator. Odd parity bit has to be generated. Okay, so 0, 0, 1, 0. Okay, again it is odd parity. Okay, because only one bit is high. 0, 0, 0, 1, 1. Input is even parity, but output is odd parity. Odd parity in the sense number of ones should be odd. So the number of ones is odd. Okay, so if it is 1, 0, 0, again it is odd parity. 1 not 1, input is even parity, but output is odd parity. 1, 1, 0 is even parity, output is odd parity. 1, 1, 1 is odd parity, so output is also odd parity. So this is with respect to odd parity generator. Whatever you give the input, whether it is even or odd, always it generates odd parity output. So we are done with the odd parity generator. Now this generated output is being transmitted across the network. That is given as an input for odd parity checker. Okay, so that checker should check whether the transmitted data is of odd parity or not. For that we have to design the circuit. Okay, so the circuit diagram is already given, so we are going to design that circuit. So that also needs a XOR gate. Okay, so XOR gate we need 7486 IC. Place the IC on the IC base as usual. Press it gently, lock it. Connect its VCC and ground. Ground is connected to the 7th pin. VCC is 14th pin connected. Okay. Now output of the generator, which is nothing but Y0, Y1, Y2, Y3 is given as an input for the checker. Okay. Output of this will be checked whether it is 0 or 1. So output of Y0, okay, connect as an input for the XOR gate. One input, second input is given for the XOR gate. Output of this XOR gate, okay, should be again input for one more XOR gate. So I will be considering this. So this is one XOR gate. I am taking this as a second XOR gate and this is as a third XOR gate. Okay, one XOR gate output, keep it as it is. Second XOR gate takes the input of Y2. Y0, Y1 given input for first XOR gate. Output I am keeping as it is. Fine. So you have Y2 connected to second XOR gate and Y3 connected to the second XOR gate. Okay. Output of this is kept as it is. So I have got two output lines. One is output of first XOR gate, which takes the input as Y0, Y1. So Y0, Y1 output is this, connected to one more XOR gate. Y2, Y3 is here connected to second XOR gate. Output of this XOR gate connected to the third XOR gate's input. Output of the third XOR gate will be the final output connected to the output logic or a logic output. Okay, so this is your final output line. So now our transmitted across the network is Y0, Y1, Y2, Y3 that is given as an input for checker. This checker will check whether the input is odd parity or even parity. If at all it is odd parity, output should be high. If at all it is even parity, it should be low. Okay, so now we'll just compare or just check whether it will give the output 1 for odd parity or not. Okay, so if it is 0, 0, 0, input is given, the output generated, odd parity generated will be odd parity number that is given as an input. Since it is odd parity, output is high. Getting? If I give a even number 0, 1, 1, 0, 1, 1 is the input given, generated is odd parity number that is given as an input for the checker. So since it is odd parity, output is 1. So whatever generator generates, so generator will generate always the odd parity. Naturally the output of the checker will be always 1 because it is odd parity. Okay. Now to check whether it produces 0 for even parity, we'll make a small change in the sense input Y0, Y1, Y2, Y3 what is being transmitted across the network will make a small change in the sense during transmission there may be some changes in the network. Some bit can be changed or one of the bit has been changed. To implement that, what I am doing here is Y0 I will connect it to input, Y0, Y1, Y2 and Y3. Okay, Y0, Y1, Y2 and Y3. Okay, so now, so forget about the odd parity generator. Now I am literally giving the input for the checker transmitted across the network. Assuming that there may be some changes during the network, I will give you even value transmitted across the network. That means 1 and 1. So input given is even parity number. So forget about x0, x1, x2. So y0, y1, y2, y3 I have given it as an input through the logic input rather than the output of the odd parity generator. To give you the demonstration of how it works, I have given the input as even parity number. So if it is even parity, the output is low. In the sense there is some mistake undergone or transmitted across the network. Some bit has been changed. Okay. If at all it is odd parity, the output will be 1. So this is the odd parity checker. I will repeat. Input Y0, Y1, Y2, Y3 is sent across the network due to some network problem, input may get changed. It may change from odd parity to even parity number. Okay, or 0 get introduced or 1 get introduced, it becomes even parity number. When it becomes even parity number, so the checker will inform or it will give an indication that there is a change in the input by giving low signal. So there is a change in the input. If at all it is odd parity, for example, if it is odd parity, output is high. So your circuit is working properly, should be high if it is the odd parity, it should be low if it is even parity. So this is your generator as well as checker. So that goes with the experiment.